Okay, so now let's take a look at our third question over here, and the question reads, find angle y. So we are looking for this angle right here. Yes, that's our angle y. Yeah. Okay, so now let's get into solving this question. Yes, I'll just write my solution right up here. Yes. Okay, so now let's take a look at this straight line over here. Yes, AB, yes, that is passing through center O, right? So we can easily tell that this is a what? This is a diameter over here. So our upper part is a what? A semicircle, and our bottom part is a semicircle as well. Yes, and then let's take a look at this other line here. Yes, DB, yes, and you can see that it's touching the what? The circle over here. Yes, it's just touching the circle or rather the circumference over here. Yes, so this line over here is a tangent. Yes, so this line over here is a tangent. Okay, so now then what would be our first step that will allow us to find angle y? So our first step over here is, let us try to find angle OCB. Okay, so our first step will be finding angle OCB. Yes, this angle right here. And let me just write my B properly. Yes. Yes. And then how are we going to find this angle? Yes. How are we going to find this angle? We're going to use a circle theorem. Yes. Tangent and radius. Yes. And this circle theorem states that the angle that the radius makes when it touches the tangent is 90 degrees. Yes, the angle that the radius makes when it touches the tangent is 90 degrees. Yes, so then what does that tell us about angle OCB? That means angle OCB is equal to 90 degrees. Yeah. Yes. Okay, so now that we have found this angle over here, yes, so this angle is 90 degrees. Yes, we found this angle here is angle 90 degrees. What then would be our second step? Yes, what then would be our second step? Okay, so now if we look at this shape right here, yes, OCB, yes, this shape, we can tell that it is a what? It is a triangle, right? Or I can say it's a right triangle, yes? And we know that all angles in a triangle add up to 180. So with that information, we can then be able to find angle COB, yes? This angle right here, yes? Okay, so now I'll give this angle, yes? This angle over here, angle COB, yes? I'll just label it as our angle X. Okay? Yeah? Okay, so now our second step will be finding angle COB. Yes? So, and we already know that angles in what? In a triangle add up to what? 180. So for us to get angle COB, all we have to do is what? We're going to add angle OCB plus, yes, angle, angle OBC plus, yes, angle COB, equating it to 180 degrees. Yeah, and we know that our angle OCB that we just found is 90, yes, plus our angle OBC was given 28 degrees plus angle what? COB, our X there, that's what we are looking for. We're equating that to 180 degrees, right? Okay, so now we can simplify. Yes, we can add these two terms over here. So 90 plus 28, what does that give us? 90 plus 28, that gives us what? 118, yes? 118 degrees plus angle COB, equating that to 180 degrees, right? And we can find angle COB. Yes, we can just isolate that by subtracting 118 degrees, yes, on this side, and we also subtract 118 on the other side, yes, and those two will cancel out. And what are we going to remain with? We shall remain with angle, yes, let me just write it here. Angle COB is equal to, yes, 180 minus 118. What does that give us? That gives us what? 62, right? 62 degrees, yes? So we have now found our angle X over here, yes? Our angle X over here, or rather our angle COB as 62, yes? So I'll label our angle X. I'll just take out my X here and just label it as 62 degrees. Okay? Okay, now that we have found our 62 degrees, we found this angle here over here, our COB. So then what would be our next step? Yes? Our next step over here is if we look at OA, yes? OA and OC. Yes? OA, yes, at this point, center OA and OC, we'll find that these two lines over here are equal, right? So we have radii, yes, that's what? Radii of what? Of a semicircle, right? So this angle is, sorry, this length is equal to this length over here, right? And if we look at this shape, what shape is that? That's an isosceles triangle, right? So I'm going to show you two ways in which we can deal with our next part, which is our third part, yes? Okay, so now, the first part, yes, the first part is we're going to use our triangle exterior angle property, yes? As we can see, we have this triangle over here, our isosceles, and we have an exterior angle over here, right? We have this exterior angle over here. And we do know that, yes, we do know that exterior, yes, an exterior angle of a triangle, yes, an exterior angle of a triangle adds up to what? The two opposite angles in what? In a triangle, yes? So that means that the two opposite angles should add up to that exterior angle over there, right? Okay, so now that means we can find this angle over here and that angle over there, right? So that would be our third step, yes? That would be our third step. Let me just, I'll do it here, yes? Our third step, I'll write it over here. Step 3, yeah? Okay, so now, these two opposite interior angles, yes? So if this is y, I'll also label this one as y, right? So these two opposite angles, yes, interior, if we add them, they should what? Sum up to the exterior angle over there, right? So then we'll have y plus y should sum up to what? 62 degrees, right? And y plus y is 2y equal to 62 degrees. Yeah, so we isolate our y by just dividing by 2, and we'll have y equal to 2 into 62 is 31 degrees. Yes, so we have found our y angle over here. Now, there's another way that you can also find this y over here. Yes, okay, so now this is the second way you can find it. Yeah, we know that this is an isosceles triangle, right? We know this is an isosceles triangle. Okay, that's fine. But then we also know that we have a straight line over here, right? And we do know that angles on a straight line add up to what? 100 and what? And 80. So that means we can find this angle over here. Yes? We can find angle AOC. yes? And how can we do that? We can simply subtract, yes? So remember the second way, yes? Second way in which we can do that, yes? Okay, so we can just simply subtract 180, yes? Minus 62, yes? And if we do the subtraction over here, what will that give us? That will give us 118 degrees, yes? So our angle AOC is 118 degrees, right? Okay, and we have an isosceles triangle now, right? And remember, yes, remember the opposite base angles, yes, should what? Should be equal, right? The opposite base angles in an isosceles triangle should be what? Should be equal, right? Okay, so then if we know that angles in a triangle add up to 180, yes? So then how do we find these two base opposite angles? Yes? Okay, so first let's get 180, yes, minus 118, yes? What would that give us? Yes, what would that give us? That will give us what? 62. Yes? And we have our two base angles, which should be equal. So it will still be y plus y equal to 62. Yes? That will be 2y equal to 62. Yes? And what does that give us? That will still give us 31 degrees over there. Yes? Okay, so now if you don't want to use to go with it like this, yes, if you come to this step, what you can just simply do, yes, what you can just simply do is 118, yes, plus y should give us what? 180, right? Okay, and we have 118 plus 2y equal to 180, right? Okay, so then we have to isolate our 2y by simply subtracting 118 there. We also do the same, yes. We have our 2y. What will that give us over here? That will give us 62. Yes, we isolate our y and we remain with y equal to 31. So either of the steps that you use, you still get, or rather you still arrive to y equal to 31. Yeah? Okay, so now let's look at our last question over here. And the question reads, find angle BCF. Yes? Find angle BCF. BCF, which is this angle right here that I have marked with my blue marker. Yes? I hope you guys are able to see it. So this is the angle that we are required to find. So the first thing that we have to do, yes, the first thing that we have to do to help us find this angle BCF is let us find angle CAD. Yes, so our first step would be finding angle CAD. Yes. Okay, so now if we look at this shape over here, yes, as you can see, we have this side and this side, they're equal, yes? So that means this shape here is an isosceles triangle. And we do know that one of the properties of an isosceles triangle is that the opposite base angles are what? Are equal, yes? The opposite two base angles are equal. So if this angle over here is 35, then we do know that angle CAD is equal to 35 as well, right? Sorry, just let me change my marker. 35, yes? Okay, so then I will label this angle right here that we just found. Yes, I'll just label it as 35. Okay, so now the second step that we have to do, yes, the second step is we have to find angle ADC. Yes, you have to find angle ADC. Yes, now how are we going to find angle ADC? We do know that all angles in a triangle sum up to what? 180. So for us to find angle ADC, we just have to subtract 180 minus 35 minus 35. Yes, the opposite base two angles over there. Yes, and then what would that give us? Yes, 180 minus 35 minus 35, that will give us what? 110 degrees. Yes, okay, so this angle ADC is 110. Yes, okay, so I'll label it over here, 110. Okay, all right. Okay, so now then, what will be our third step? Our third step now, let us try to find, yes, our third step over there. Let us try to look at the shape inside this circle. Yes, so we have our point ADCB. Yes, as you can see, these are points on a circle. Yes, and if you look at the shape inside this circle over here, we can see that it's a what? It's a cyclic quadrilateral. Yes, and we have a cyclic quadrilateral circle theorem that says that opposite angles in a cyclic quadrilateral add up to 180. So with that being said, we can then find angle CBA. Yes, let us find angle CBA. Yes, and you can see that ADC, yes, is opposite to what? To angle CBA. Yes, okay, so then how then do we find CBA? We find CBA, yes, by what? By saying 180 minus 110. Yes, 180 minus 110, and that gives us 70 degrees. So our angle CBA is 70 degrees. Yes, okay, so let me label that as well right here. Yes, that's now 70 degrees. Okay, now if we look at triangle ACB, yes, it's formed from what? From a diameter. Yes, so that means angles ACB, yes, angle ACB is what? Is a 90 degree angle. Yes, okay, so our fourth step is finding angle ACB. Yes, ACB, which we have found to be what? 90 degrees over there. Yes, okay, so now then, what would be our fifth step? Our fifth step is trying to find angle BAC. Yes, okay, so our fifth step, we want to find angle BAC. Yes, and we know that ACB, yes, that is a triangle, and all angles in a triangle add up to 180. So we can find angle BAC, right, by saying 180 minus 90 minus 70, right? Okay, so then what does that give us? Yes, what does that give us? I don't have to use my calculator. That will probably give us, that should give us 20 degrees. Yes, okay, so now that we have found our angle BAC, yes, this angle right here is 20 degrees. Yes, okay, now that we've found our angle BAC, which is 20 degrees, our next step then is to find angle BCF. Yes, BCF. How then do we find angle? Yes, this is our last step. Angle BCF. We're going to use a simple theorem called alternate segment theorem. Yes, alternate segment theorem. And what does it state? Yes, it states that the angle between a tangent and chord drawn from a point of contact, yes, is equal to the opposite angle subtended by the same chord. Yes, so this angle over here, yes, between the tangent and the chord, yes, drawn from a point of contact, yes, is equal to the opposite angle, yes, is equal to the opposite angle subtended by what? By the same chord. So then that tells me that angle, yes, angle B, yes, BAC is equal to angle BCF. Therefore, angle BCF is equal to 20 degrees. Okay, so there we go. We have now solved our last second theorem problem. All right. Thank you so much. I'll see you in my next lesson.